Hi, welcome to section number 3. We will talk here about advanced Python topics. In volume 1, we will talk about logging. In volume 2, we'll learn how to search for specific patterns in strings using regexes. Then we will take a look at function decorators and context managers. In video 4, we'll talk about generator expressions and generators. Then we will talk about magic methods as a way to enrich classes with the emulation of built-in types. Then, in video number 6, we will talk about metaprogramming in Python. Then, in video 7, about functional programming in Python. And in the last video, we will talk about being Pythonic in the code you write. So, in this video, the topic is logging. So, we will talk about why logging is useful. We will take a look at how Python helps us providing high-level abstractions for logging, such as loggers, log handlers, and log levels. And then we'll take a look at the sample code. So logging basically is a way of routing application events called logs to some channels that can be of multiple fashions. For example, you could route them to files, to standard output, standard error for processes, or to a remote system, even using a TCP IP connection. This usually is useful for two purposes. One is tracking the events history for auditing processes, and the other one, of course, is debugging. So this is the abstraction that Python provides us for logging. So Python gives us logger objects. They act on a file-wide way, and to each logger, we can attach a log level. A log level is basically the severity of the message that is being dispatched. And as you see on the right of the screen, we have this scale of severity starting from debug, which means very low risk messages, up to the critical level, which is the most severe one and the one that hopefully will be more in the need of taking care about. So for each logger, we assign a default login level, and that logger will basically pass all the messages that have that level up. So to each logger object, we can attach one or more logging handlers. So we can attach different handlers, and each one is bound to a specific channel. Say we could add a handler for login to file, for example, and another one to log into the standard output. Each of them has a specific log level bound, and this is a further filtering of the severity of the messages. Then optionally, each handler can have a formatter attached to it, which is basically a syntax to specify how the login message will be written. So say we are producing a warning log message, we pass it to the logger dispatches that message to all of its attached handlers, and based on the log level, both the logger upstream and then the handlers downstream filter the log messages that are dispatched. So the ones that pass through this filtering are effectively dispatched to the channel bound to the log handler. Let's take a look at some code. Here I prepared for you a specific class called account, which modelizes a bank account. What we can do basically is deposit and withdraw currency to that account. And every time we create an account, we log an info level message to the logger that we inject into the constructor. And every time we deposit, after a few assertions, or we withdraw, if any of these assertions fail, we just catch the error, the thrown error, and log an error message telling why the operation has failed. So I just want to put this into practice, and I want, in this example, I created for you a console logger, which basically is printing on the standard output the outcomes of such application events. So what I do here is to get a logger object, and this can be done by importing the logging library, which is in the standard Python library. And what I'm doing here is telling, okay, I just want to get messages with level info up. So what I do here is instantiate an account with currency euros, and then do some operations. And as a last step, I just want to log a warning message that recaps the final amount for the account. So if I run it, what we do is that we see all the logs that were embedded into the operations of the account to be printed on the standard output. Another useful example is logging in files. So in this example, we just instantiate a file logger. What we do basically is to obtain an instance of the logger from the Python login library, and then we create a specific file handler for logging to file. What we do here is to build the path of the target log file, which is going to be into this folder where the code lives. And then we obtain, using also the standard library, a file handler. And this handler has been set with login level info. Moreover, what I want to do is to format it to that file handler logger. So what I do here is I instantiate the formatter, I attach the formatter to the handler, and then attach the handler to the logger. And what I do is exactly what I did before with the account. So I'm expecting to see the same log messages, but this time they will be logged to a file. So let me run this example. Okay, this tells the process ended correctly. And as you see, a new file has been created here called account.log. And this file contains the same log messages as we've seen before, but they get formatted in a different way because we set up a formatter. So in this lesson, we learned why logging is useful, and we've learned what are the Python high-level abstractions for logging, which are loggers, log handlers, and log levers. And then we've seen examples of logging.